Hi, my name is Robert Schumann. I'm from Juniper Networks, and in this video I'm going to go over Project ARCUS. So ARCUS was a collaborative effort between Microsoft, AWS, MITRE, and Juniper. And where it came from was a challenge from the Chief Architect's Office of the Air Force to demonstrate a multi-vendor, multi-cloud solution, really about application resiliency. So we collaborated between Microsoft and AWS prior to the DFIDIC conference in Montgomery, Alabama, that happened in late August. And there what we set out to do was to demonstrate true application mobility, where an application can live in any cloud, in any edge, essentially anywhere, and be available all the time. And so what we're doing was using the edge platforms, using the IaaS platforms to provide compute and store, and to connect the clouds and the edge together using the integrated warfighting network architecture. And then as part of the effort, when we were actually at the conference, we had an extra opportunity, essentially a bonus to this, was to actually integrate with the team from MITRE that works on Platform 1, specifically the Yoda box. And what that architecture looked like is basically this. So it's a whole of nation approach to infrastructure, infrastructure as code. And so we have, in this instance, an application that's going to be hosted essentially available from everywhere. So in AWS, in the Microsoft Cloud, out at the edge, so the Azure Stack Edge, the Snowball Edge, as well as the Yoda box. And then connecting all that together is secure vector routing. So this is providing the ability to have that user that's connected into that wireless access point to be able to access that application regardless of where that container is currently running from. And so the demonstration itself, what we did is we looked at, all right, we have our application. And so in the video that I'll be showing shortly, you'll see that up on the screen. And basically, I'm accessing the application, and it's just on a single address, and I'm pinging the application. And what I'm simulating is, all right, it's currently running on the Yoda box. We have a Session Smart Router running on the Yoda box. And if I disconnect it, right, I want to maintain connectivity to that application. And so the application simply moves. So the Session Smart Routing and the secure vector routing that's there is able to detect that outage and move that user to where that application is now accessible from. And then we pulled the snowball out of the environment. So that's no longer there. The application then moves up into the Microsoft Azure cloud. So it's running from there, we're accessing it there. Then I removed some of the WAN connectivity, right? Simulating resiliency of transport. So going from the terrestrial connections that we had to LTE, and then putting those back into the network. And then reestablishing the connectivity of the snowball. So we're able to then say, all right, well, a faster, closer instance of that application is available. Let's move that user to be using that one. And then when we reattached the Yoda box, we're then moving that user over to the instance of that container, that application's running there. In the video, what you'll see from a component standpoint is the Azure Stack Edge that's sitting underneath the SSR 120. That's the hardware platform on which the SSR is running. The SSR software is running on the Azure Stack Edge, the Snowball, as well as the Yoda box. So let's get into the actual video.
My name is Robert Schumann. I'm from Juniper Networks. We've been working with AWS, Microsoft, and MITRE on putting together a demo for a resilient tactical edge as well as resilient clouds using both IaaS providers and different actual platforms out of the edge. So we're using the Azure Stack Edge product. We're using the Microsoft Snowball, or the AWS Snowball, as well as the MITRE Yoda box. So we have all those in front of us. Every single one is running the exact same application. We're also running the same application out in the cloud as well. And so what I'm going to go through is basically a short demo showing the failover between the AWS Snowball to the Yoda box and then out to Azure and then back, as well as showing resilient WAN connectivity as well. So this is our application. It's really, really simple. It's just hosted on Yoda, and then we're just refreshing this to kind of show it. And then I'm pinging the application so you can see the impact of latency as we make changes to things. So I'm going to go ahead and unplug the Yoda box. So it's now unplugged. And then what we're going to see is basically now we're sitting on the snowball. So I'll go ahead and unplug the snowball. So now we're going to go up to Azure out in the cloud. So you can see our latencies jumped up, hitting that application. It's now hosted in Azure. And then I have 3 different WAN connections. So 2 of them are terrestrial, and the other's LTE. So I'm going to pull the 2 terrestrial connections. So you can see we're now sitting on LTE. It's a little bit slow, but it's still working. I'll plug both those back in. So we'll see in a couple seconds is our latency is going to drop back down as we pick up those pads. And then we're going to go and plug back in this snowball and then the Yoda box in a second. So latency's drop back down. We'll plug the snowball back in. So now we're back on the snowball, so there it is, and then we'll go ahead and plug in the Yoda box, and then in a couple seconds we'll see this flip over to the Yoda box. And there we go. So completely resilient, using multiple different vendors' solutions, open source from the 2 largest cloud providers on the planet, and able to use any type of comms path that we have as long as it's IP. So thanks for watching.